So carbon is very versatile in nature. We already know that carbon makes covalent bonds by sharing the electrons in various elements and compounds. We have seen the simplest carbon compound, that is methane. And we have seen that many things are there which we use in daily life are made up of carbon compounds. The numbers of carbon compounds whose formula are known to chemists was recently estimated to be in millions. This outnumbers by a large margin the compounds formed by all the other elements put together. Why is it that this property is seen in carbon only, not any other elements? So why carbon is so much versatile in nature? Why carbon can make so many compounds and elements? The nature of the covalent bond enables carbon to form a large number of compounds. So two main factors noticed in the case of carbon are: first is the ability to form bonds with other atoms of the carbon. It gives rise to large molecules. This property is called catenation. Due to the property of catenation, carbon can make the bonds with other carbon atoms. Carbon can form 4 covalent bonds. So that means one carbon can attach with 3 other carbons. And this property gives rise to branched chain of carbon. Even because of this property, carbon chains can be arranged in ring form also. Apart from the ring structure and branched chains of carbon, carbon can form a long chain of carbons. Carbon has the unique ability to form bonds with other atoms of carbon. Because of this, carbon atom can form double bond with other carbon. Carbon atom can form triple bond with other carbon atoms. Compounds of carbon which are linked by only single bonds between the carbon atoms are called saturated compounds. तो saturated compounds किसको कहते हैं? जब एक कार्बन दूसरे कार्बन से सिंगल बॉन्ड के थ्रू अटैच हो, उन कंपाउंड्स को हम कहते हैं सैचुरेटेड कंपाउंड्स. तो इसका रिवर्स हो जाएगा अनसैचुरेटेड, यानी वो कंपाउंड्स जिनमें कार्बन एटम्स दूसरे कार्बन एटम से डबल बॉन्ड या ट्रिपल बॉन्ड से अटैच्ड हो. Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated compounds. और ये जो प्रॉपर्टी है कैटिनेशन की, ये किसी भी अदर एलिमेंट में नहीं है. Only carbon compounds are having this property. That means an oxygen atom can form the bond with only one other oxygen atom and they form O2 molecule. Rarely one oxygen atom can form the bonds with other 2 oxygen atoms and they form O3 ozone molecule. But one oxygen atom can never forms the bond with 3 other oxygen atoms. So O4 molecule does not exist. Same case is with hydrogen. Hydrogen can form one bond with other hydrogen atom and form H2 molecule. But H3 molecule does not exist. Likewise the case with nitrogen. Nitrogen atom can form the bond with other nitrogen atom and forms N2. But N3 does not exist. This indicates that no other element exhibits the property of catenation to the extent seen in carbon compounds. In carbon family, we have another atom named silicon. Silicon forms compounds with hydrogen which have chains of up to 7 or 8 atoms. But these compounds are very reactive. Apart from catenation, the carbon-carbon bond is very strong and stable. This gives us the large number of compounds with many carbon atoms linked to each other. So that's why carbon is the backbone for all organic matters. The second property which makes the carbon versatile in nature is its valency of 4. So carbon can form 4 bonds. It is capable of bonding with 4 other atoms of carbon or atoms of some other monovalent elements. Compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, and many other elements, giving rise to compounds with specific properties. The bonds between the carbon and other atoms are very strong. That's why these compounds are stable. But why carbon can make such strong bonds? The reason behind it, the size of the carbon atom. Because the size of carbon atom is very small. This size enables the nucleus to hold on to the shared pairs of electrons very strongly. कार्बन एटम का साइज बहुत छोटा होता है और छोटा होने की वजह से जो न्यूक्लियस है वो शेयर्ड इलेक्ट्रॉन्स को स्ट्रांगली होल्ड कर सकता है. अगर साइज बड़ा होता तो इलेक्ट्रॉन्स दूर होते. जितना बड़ा साइज होगा इलेक्ट्रॉन्स के शेल्स भी उतने ही ज्यादा होंगे और न्यूक्लियस उसको बाइंड करने में उतना ही वीक हो जाएगा. तो जितना स्मॉल साइज होगा एटम का उतना ही न्यूक्लियस इलेक्ट्रॉन्स को टाइटली बॉन्ड करके रखेगा. The bonds formed by elements having bigger atoms are much weaker. So the conclusion is two main features which are seen in the carbon are tetravalency and catenation property. So due to these two properties, carbon can give rise to a large number of compounds. Many have the same non-carbon atom or group of atom attached to different carbon chains. कार्बन अपनी दोनों प्रॉपर्टीज टेट्रावेलेंसी और कैटेनेशन के कारण दूसरे एलिमेंट्स या एटम से भी बॉन्ड बनाता है और अदर कार्बन एटम से भी बॉन्ड बनाता है. यानी जो कंपाउंड्स कार्बन से बनते हैं उसमें कार्बन एटम्स भी हो सकते हैं या फिर नॉन कार्बन एटम्स भी हो सकते हैं. सो सबसे पहले जब ऐसे कंपाउंड्स मिले तब ये सोचा गया कि ऐसे कंपाउंड्स जो कार्बन एटम से मिलके बने हैं या फिर कार्बन और अदर एटम से मिलके बने हैं वो नेचुरली पाए जाते हैं और सिर्फ नेचर से ही इनको निकाला जा सकता है. लैब्स में इन्हें नहीं बनाया जा सकता. पहले यही माना जाता था बट ग्रेजुअली साइंटिस्ट रियलाइज्ड कि ये कंपाउंड्स हम लैब में भी बना सकते हैं. So these compounds were initially extracted from natural substances and it was thought that these carbon compounds or organic compounds could only be formed within a living system. That is, it was postulated some living force was necessary for their synthesis. That means it was thought that organic compounds can be synthesized only in a living system. But a scientist named Frederick Wohler disproved this. He prepared urea from ammonium cyanide in 1828 and he proved that organic compounds can be prepared in lab also. Saturated and unsaturated carbon compounds.